Oh, no, sorry. Yeah, yeah. It can't be more than 1, but it can be less than 1. Yeah. Can't it? So you can think about this. So the probability of A is 0.3. I'll just change it over here. Probability of B is 0.8. Probability of some intersection, which we're going to look at, and that can only be like this. Yeah, the maximum value. That's why I drew the diagram, but I went too fast. Okay, so what's the maximum value or the minimum value of x then?
Yeah, it's 1.1 minus 1.
Yeah, so you can rearrange this and you get 1.1 over here minus that 1. X has to be, so x has to be 0.1 or above.
Is that how I have to write my answer? Or do I just
You can say the minimum value is 0.1. You can do whatever calculations you want. I think it just said determine and didn't say justify in any way. So the lowest value here is 0.1. It could be more than that. It could be a greater intersection of the two. And that's what we're going to look at in the next one. What's the biggest value?
when it's a subset.
Yeah, when it's a complete subset, yeah.
And when A is a subset of B.
Yeah, so when all of A is contained in B. So if that starts to move like more over, although that's not the way it works, but if this is B, which has 0.8, and in it was included 0.3 from A,
So the maximum possibility would be 0.2.
and then there's 0.2 on the outside. Does that make sense? So basically, if A occurs, B also occurs kind of thing.
But why is it 0.2?
Well, that's what's left over. So there has to be some probability of, it's like, you think of maybe subject choices? Oh, maybe I should have come up with a good idea for this. You have to do, if you do, I can't think of one that logically makes sense, but let's say anybody that does, these are all people who do languages. B, you do a language, and then
language
0.
A, language B then maybe? Because if you do, language A, you'd be outside of that, but if you did language B, you could be like language B French or language B Spanish or something like that.
Well, I was thinking that these people don't do languages, whereas if you do Spanish, you are doing a language. That would be part. So that's the Spanish. This is, yeah. And then everybody else. Maybe that's an example. But the idea is that, yeah, everything in A could be in B. So that would be the maximum intersection would be everything in A is also included in B. So that would be the maximum. So this 0.2 joins this 0.1. Okay. Yeah, there's another one a bit like that. Question 8 was a bit nasty, wasn't it? Okay. Question 7 then. Some differential equations. Now there's mixed responses from you guys as to whether you had done this before.
I just think I was sick. I think I did.
You think
Wait, no, I did this.
some of you have done it, some of you haven't. Okay, so we got this.
Oh, question 8?
Yeah.
Question 7.
Oh, question 7.
Oh, question 7, yeah.
You guys have done it?
I'm not sure.
Dude, I don't rearrange it. No.
If they were in Vietnam, that means I
Question
did.
7.
Not in
Right here.
You.
I believe that we've done this.
No, I don't know if you may have done it,
Well,
as in you've done this question, but have you done this topic with Mr.
yeah,
Gide?
One single day.
One single day.
Is this just an implicit differentiation question? Yes.
Okay, so it's differentiation, yeah. So the first thing we read the question first of all and consider the curve, show that there's no local max or local min for the points where x is greater than 0. Okay, so local max, local min, we're already thinking about, right, we need to get dy dx equal to 0 because that's where maxes and mins occur. Right, how do we derive this? Well, we got to derive both sides with respect to x to get dy dx. So that's perhaps, okay. You know how to do this, Debbie?
Yeah, I did it.
Okay, what do you do?
So you start with 2y dy dx.
No, explain what you're doing.
Oh, you differentiate it first. So you
Okay,
end
what-
up with I don't know the name of it, but I know how to do it. So you have
Okay,
two
all right.
y,
Yeah,
one
no, I don't want you to read out what you've done. Explain. Yeah.
So you differentiate both sides.
Yes.
This one you differentiate using, I'm not sure if it was chain or product.
It's definitely product rule. It wouldn't be chain rule. So this and this times this is a product. Yeah.
Yes. So you differentiate just the y squared on one, and then you differentiate the inside on the other.
Okay.
And you add them together, and then on the other side it's just 8x.
Okay.
So you have to remember.
Right. Stop. Right. So this is a product rule. We got two things here, u and v. So the product rule is the first times the derivative of the second plus the second times the derivative of the first. So the first is pretty easy. It's just x squared plus y squared. I want to times it by the derivative of y squared. 2y?
Yeah, 2y dy over dx.
Yes, 2y dy dx.
Oh yeah, we've definitely done it.
Oops.
The one I was confused about was like,
Why would you put it on the inside though, sir? Why would you put it on the outside?
Why would I put it on the outside?
No, like on the other sides, that it starts with 2y. That's just
Doesn't matter.
No, that doesn't matter. It doesn't matter. Yeah, it doesn't matter what order. Okay. Then I have to do y squared by the derivative of this. So what's the derivative of x squared plus y squared? 2x 2x plus 2y dy dx. Very good. Okay? And that does equal 8x. Very good. Okay, so at this stage then, what's my goal? Yeah, I want dy dx. I want that on its own. So I got a bunch of stuff there. Now it's an algebra skill.
you factor it out. I'm pretty sure you factor it out.
First of all, I'm going to multiply this. I'm going to leave this the same. I'm going to multiply this out. 2xy squared plus 2y cubed dy dx is equal to 8x. So I want dy dx on its own. Let's subtract this over, and let's factor out dy dx out of these two. So on this side, I'm going to have dy dx factored out, so I can have dy dx equals. All of this is still here. X squared plus y squared times 2y. Also, this plus 2y cubed is here. That's everything with a dy dx. And this thing I'm going to subtract over. I think that's correct. And then I can just divide this over under here, and then I'm done. That just, okay, I'm not going to rewrite it, but that just divides down over here. Not done yet. Then we got to go and this thing. The reason I kind of ignored this is because when I let this equal 0, then the denominator is kind of going to go, isn't it? We only really care about the numerator. So when dy dx equals 0, I'm going to go straight to this, and I'm going to give you a second just to make sure you're on the same page as me. That has divided down here, and now because this equals 0, then the denominator multiply both sides and it's gone.
Oh, do you factor out the 2y over there?
No, you don't factor it out. When you move the denominator over and it becomes a fraction, if the fraction is 0, it just means the numerator is 0. So you just only take the numerator and pull it to 0. And then you can solve the equation.
Maybe I'll write it, it might be easier. Dy dx equals then 8x minus 2xy squared, all divided by this. And when dy dx equals 0, this multiplies and goes to 0. Okay, need to solve this then, don't I? Solve it by factorizing out maybe 2x leaves behind 4 minus y squared equals 0. Okay, so both these, if they multiply, using null factor law, will.
X equals 0 or y equals 2?
So this gives x equals 0. And this gives y squared is equal to 4. Y is equal to plus or minus 2.
And then for the balance.
Yeah, so.
There is no solution.
Yeah, so here's the thing. Show that there's no local maximum endpoints, but we got some points for y. And then we go, oh, the question at the start said minus 2. Y has to be between minus 2 and 2.
But it is neither.
So it is neither, so there's none. So you point, you'd point to this. You point to this, therefore not valid or something, you would say, because it's outside the bounds allowed.
You do the 3 dots.
Like, you don't have to put the 3 dots, yes. That won't make or break. The 3 dots means therefore. Why does it mean therefore? I'm not really sure. It just does. It's like saying why does the equal sign mean equals? Why did they pick that symbol? I'm not sure. But that's what therefore is. Okay. So you've done this before? I wasn't sure. That's good.
Yes.
Some people are a bit rusty on it, maybe?
I wasn't there.
Okay, well, we'll do it again. We'll do it again. But I'm not sure how much time we can spend on it. But
I
we'll,
usually do with differentiation such.
yeah. We have to finish calculus and you have to finish probability. Nope.
Wait, is calculus it?
Once we do probability and calculus, then we're done, yes. Yeah, you have to make, you have to do, no, paper 3 just is no new stuff. It's just including everything. You haven't done McLaren series, I don't think? Differential, have you done differential equations in general? The rates of change, the homogeneous ones? Okay.
I feel like we did do rate of change. We did it for like 2 days.
Like the ladder slipping down the wall, have you done that stuff?
We've done rate of change.
Yeah, but for like 2 days before the semester.
Okay. Next question. We have this one, which I didn't really like. So I didn't like, no. First of all, it wasn't a test. It was homework. Because I don't like a question doesn't mean that the IB won't ask it. Yeah. Yeah. All right. Consider the case. All right. So so we got a bunch of stuff. There's this 0. We're only talking about from 0 up to some value of a on the x-axis. That's crucial throughout, I think. The first thing we need to look at is consider the case where k is pi over 2. Okay, I will. So f of x is equal to cos x minus pi over 2. So we'll look at that. By sketching a suitable graph or otherwise, okay, so we might as well sketch a suitable graph. Try to do a quick sketch. 1 minus 1 for cosine. The normal one I'll draw here. Starts at 1, doesn't it? I'm drawing the regular one, and then we'll draw the translation. Something like that, maybe. That's 1, that's minus 1. What's the point is this? Where is cosine 0? Oh no, this is the original. This is sorry, this is cosine x.
Just cosine?
Yeah, this is not. Pi over 2, pi, 3 pi over 2 is here, and then reaching another high point, 2 pi. Very good. Switch color of pens to see what it looks like when it has been translated. That's translated, which this.
That's the default.
But you have to do line test.
Okay, first of all, I'm just looking at sketching, part A. Consider, what does it say? Consider, by sketching a suitable graph or otherwise, find the largest value for A for which it exists. So we haven't done the,
Move it to the right.
yeah, so this minus suggests I move a pi over 2 to the, shift pi over 2 to the right. So that means that this high point is now this high point, isn't it? Okay, and then it follows, yeah, it follows here and comes back up and does, it's slightly behind its buddy. Okay, and now I need to think about, okay, where is it valid? For it to be valid, is that what it says?
Valid for F.
For it to have an inverse, it has to pass the horizontal line test.
How does that work?
It can only be at a certain value once, basically.
Yeah, it can't go through it twice, yeah. The vertical line test is for a function to be one-to-one, a normal function. For it to be called a function, it has to pass the vertical line test, which means its inverse has to pass the horizontal line test.
So I thought vertical was horizontal.
Okay. So, yeah. So, like, if I had this domain stuck from 0 up to pi, that would not pass the horizontal line test because it'll go through it twice. It goes through here and here. So that wouldn't have an inverse function. If I went up to pi, it wouldn't have an inverse function. So I have to stop it at the very point it starts coming back on itself, when it starts to fail. And the whole thing is it says to start at 0, so I don't really care what happens before 0.
Yeah.
So from here up to here would pass a horizontal line test, but as soon as I go past this point, it fails the horizontal line test. So A has to be pi over 2.
Isn't everything pi over 2 in this question?
No, well, maybe. So A is pi over 2.
Functions doesn't work.
Yeah.
It doesn't have horizontal line tests.
For the inverse to be a legitimate function, the original has to pass the horizontal. So it's like the opposite, because when you get the inverse of this, the inverse has to pass the vertical line test. So the y's become the x's, so it has to pass the test in the other direction for its inverse to work. Not sure.
When it doesn't pass an intersection point, it just fails.
Yeah, it won't. Like you can get the inverse pass, but it won't be a function. It'll be a relation. Like you could draw a diagram. Yeah, sure, you could draw this diagram like this, but it wouldn't. It would fail the vertical line test.
That is how a function works. You can't
Yeah,
Pass over the
y's
same.
for 1x.
yeah. So that's
Or inverse can't be multiplied.
yeah. So that's what I'm getting at here. Right. So hopefully you're picking that up from here then.
Basically making sure that like it follows that rule.
All right, part B then says something pretty similar. What value is it if k is equal to pi? So it's gone even further to the right. Now I might draw this in a different color. If I do. So it's gone even further to the right. And now this is included. I think it's this one. This one here, and it goes up, and then it comes down. Okay, so the red one will be a valid function starting at 0. I don't really care what happens before 0 yet. Here up to here. And then it turns back on itself. So the second answer for part B then is A is equal to pi. Part C then. Yes. All right. Part C then is where you have to think. What's coming next? What's coming next is this part of the graph, isn't it? Oh, that's badly drawn. Like this part, which is not included. This part's coming next, isn't it? It's going to slide over a bit. That's what it's thinking about. It says in the next part of the question, what happens when it's gone past this pi point up to 2 pi? This shift is going to slide over here. What happens then? Does anyone have an answer?
I mean,
I
if
do.
it,
I have an answer, but I came to this answer from my tutor, and I don't completely
Yeah,
understand
yeah,
how I got
I
there.
mean, I
Also-
understand it.
Yeah, okay, go.
So it can't, what's it? Any
So-
more than, what's it? Moving it any more than pi means that it automatically fails the horizontal line test because you're, what's it, doubling up by extending it any further.
Yeah.
That's the minimum point. at the
Yeah,
bottom.
so if this bit moves over a little bit,
So at exactly pi is the.
then you're starting at 0, then you only have this far to work with. That's as much as you can say.
From the minimum to the maximum.
As this bit comes over,
Whereas, okay. Then you can't, like, it fails the line test at the bottom there. Right?
yeah.
Um,
So it has a bunch of answers.
What's the maximum for which
But we're answering in terms of k.
Yes.
k
So
equals pi then?
k equals pi. K can equal pi.
Sorry, no, k.
So
Is it
k's
not
highest,
k equals pi?
k's highest potential point is 2 pi. So if pi is the highest we can go.
So if it's minus pi, and a equals k minus pi.
Okay, yeah, so the answer is A equals K minus pi.
Or no, it's pi minus k minus pi.
K minus pi, I think, yeah.
Well, this k's limit is 2 pi. Right?
Look at the question.
Why does this work? Why does this work?
But we've shown that there's the highest it can go.
Oh, because k is only in between pi and 2 pi, so therefore minus pi ensures that it will always stay within the boundaries that ensure the inverse function exists.
And then why do we do a?
Hmm.
Because it asks for the answer.
We'll
So-
just make sure
And k is the range.
Yeah, so A will be some, yeah. So A in this case was pi over 2. Like if your K move was, let's say, 3 pi over 2, if K was 3 pi over 2, what would happen?
It's just how
then it'd just be pi over 2. Why?
It's a duplicate.
Because it loops back.
Because at this bit would be down here, and then at this point it would start to come back on itself. Like this bit is shoved over here. And at this pi over 2, then it starts to come back on itself. So it's always going to be between, I suppose, 0 and pi. Okay, I don't know if that, it's really hard to explain. You kind of get it or you don't at this one. But yeah.
Yeah, you just have to actually look at it.
I should have probably brought Desmos into this so we can see it sliding over because there's too many graphs here. Maybe I'll look at this again on Thursday. But when this moves, you were noticing this part of the graph move over, and it.
I get that. part,
Sure, it's
but
a
why-
discrete probability homework, do you know Tuesday?
Thursday, yeah.
Why do we say that A equals K naught?
Because you're asking for the answer in K, and K is a range of values.
Yeah.
So K can be anywhere between pi and 2 pi.
Yeah.
But you want the final answer to be pi or less than pi.
Yeah. Yeah. So pi is the maximum kind of value, and 0 is the minimum, I suppose. Yeah.
Okay.
Okay. So you're supposed to answer that in 5 minutes, that question. That took us about 8. All right. This one you haven't done. Or you have done. Okay. I'll do it. Maybe it'll make sense. That was just so you have the solution. Okay, we have this. It tells us these are like initial conditions. Y is equal to 2 and x is equal to 1. You're going to use that to find c later on. The constant of integration. This is an integration question. But it uses a lot of differentiation to get there. By using substitution solve, so they give you some substitution that you have to use. Y is equal to, what is it, Vx. Very good. Okay? Vx, yeah. And they want the answer y squared equals a function of x, fx, or a function with just x in it. Okay. So they want that as their goal, y squared equals. Okay, so v times x is a product. And just as a side, to get the derivative of a product, we already used the product rule. We used v times, with the derivative of x, dx dv, with respect to x, dx dx. Okay, so we're deriving it with respect to x. So everything is derived with respect to x. Which, handily enough, changes to this, because dx over dx is just 1, the change of x. Whatever the change of x is over the change of x is just going to be the same number, whatever it is. Okay. This we're going to put in on the left-hand side. So this is an equivalent for dy dx, and I'm going to put this in. So this is a substitution thing.
That's what we're substituting?
That's one of the substitutions. The other substitution is going to be for y on this side, which is vx. Okay.
I kind of figured that's what it is.
Okay, so that's like a side. You can put that on the side or underneath. Now I'm going to use this over here. V plus x dv dx is equal to, now y is going to be replaced with vx. So vx squared. So I don't have y anymore. That's my substitution done. I don't have dy and I don't have y. I have v's and I have x's. Minus 2x squared all over x times Vx. Okay. Now I want to split this up into two separate terms so it can be easier manipulated and I can see some cancellations is going to happen. That is Vx squared, isn't it? And minus 2x squared over Vx squared. See that? Just working with the right-hand side here. Just the right-hand side for now. Oh, it is v. Yes, I knew it. Yes, thank you.
With vx, it just be vx squared. That just works. So you can just multiply the x with the vx, and it's vx
Yeah. Okay, yeah, I knew I made a little mistake. I was figuring out where it was. Okay. This is going to cancel. The x squareds are going to cancel. One of the v's is going to cancel. So this term is just v. And this term, the x squared, is it 2 over v? Yeah. Minus 2 over v. And on the right-hand side, I have v plus x dv over dx. Okay, so I need to integrate at some stage. So I'm getting to a stage where I can integrate the v's and the x's separately. I can't do it when they're all stuck together like this, all mashed up. If I can get the v's on one side and the x's on the other side, I can then integrate. That's what I'm looking for.
Subtract by v.
Yeah, first thing, very easy. These v's are going to cancel, so I'm going to be left with x v dx is equal to minus 2 over v. And then I'm going to do like cross multiplying, or that's a v, not a u.
Oh, that's a v.
Yeah. So over here, I'm going to have v dv is equal to minus 2 over x dx. So you know when you integrate with respect to x, so that's you get a dx there and a dv. So now I've separated. The x's are one side, the v's on the other side. There's a cross multiply type thing going on there. I'll give you a second to figure it out.
Why does x dv over dx become dt?
So the v, I multiplied both sides by v, cancels here. Multiplied both sides by dx, divided both sides by x, and it all kind of tidies up a little bit. Now at this stage, I'm ready to integrate. So I have to be able to integrate both these things. The integration of v dv is?
0.
No. Add 1 to the power, divide down by new power. V squared over 2.
Close enough.
Yeah, integrate, yeah. Oh yeah. It'd be 1 anyway if it was differentiated.
Minus 2x
So what's the integral of minus 2 over x?
minus 2x squared over 2.
No.
Minus 4x over
Minus 2 ln x. That's poor. Yeah. So 1 over x integrates to ln x, doesn't it?
Yes, that
c over x.
Okay, plus some constant. So the constants on both sides would add to form a constant or subtract to form a constant. So we only put the constant in once.
And it doesn't matter which side it is.
There's
No.
no y.
You're right, there's no way. I'm not finished yet. We've done it's like integration by substitution kind of way, but we're going to come back to this at some stage. We're not finished. So where are we at? Look at the number marks for the questions 8. This should take us 10 minutes max.
Well, now you have to substitute a number.
Yeah, now I want to actually get what c is, and then I'm going to put in for v, and then I'm going to make y squared equal. So in the steps I need to follow, I don't want a c in my answer, I only want x's and y squareds. Okay, so maybe you can see v squared will probably become some sort of y squared eventually, but first I want to find c. How do I do that? I have some initial conditions, like y is equal to 2 when x is equal to 1, which is no good because we want a v. But we have a relationship between y and v that I can get a v. Okay, so what's v? If y is 2 and x is 1, v is 2. Yes. That's from y is equal to vx. Okay, so now I know v is 2, so that's 2 squared over 2 is equal to minus 2 ln 1 plus c.
So in the question it says y plus 2x and then you substitute it into y plus 0x.
So what's ln 1? What's the ln 1?
E?
No.
No, e to the 0. C is 0 then.
1. Wait.
Is 0, right?
C is 2.
ln 1?
When some
c is 2, yeah.
Is ln 1 0?
Yeah. ln 1 is 0, so that's gone.
Because e to the
That's divided by 2, and c is 2.
and x to be 0 then.
Yeah, ln 0. Yes, so to what power? What is the power?
Yeah.
0. Okay, so 2 is c, which means I can go back here, put 2 in. I'm also going to go back and put for v squared in. I read. So where am I? V squared is now, v is y over x, isn't it? If I did a little rearrangement here. Okay, so I'll put that in. So that's y squared over x, 2x squared. I've replaced that v with this. No. No, that's right. That was right. That was right. Yeah, just making sure. Minus 2 ln x plus 2. So 2. So this is v has been replaced. This v has been replaced by y over x. Because I want y in my answer. The answer says what's y squared basically.
Oh, gotcha.
Right. So we're there. We're pretty much there. We just need to get rid of that 2x squared over here. Whatever way you multiply it over, it's going to give, like you can factor it out if you want. I think the way I wrote it is 4x squared 1 minus ln x. I think that gives it. So that 4x squared is here, and that's 4 times.
You just substitute v squared with y squared.
Wait, did you take the minus 2 common? Oh no, you just took 2 common. Yeah.
Ah.
You just took 2 common and multiplied by 4x squared.
Okay, not great. And there's a part B. So it says we have this derivative. You actually could have done part B without doing part A, I think. They've given you the derivative, and they said the points of zero gradient, so where the derivative function is equal to 0, there's 2 straight lines in this form. So what we're going to do is just let this equal 0 and see what happens. Because it says where dy dx equals 0. So y squared minus 2x squared over xy equals 0. Multiply by xy, we get y squared is equal to 2x squared equals 0. So y squared is equal to 2x squared. Square root both sides. I get y equals plus or minus root 2x. That's the answer. What's the answer for m? Because it's in the form y is mx and there's no plus c, then that is that. M is plus or minus root 2. We just got it straight away. So that could have been done independently of part A, which may be a lesson. Okay.
2 of the questions you can do, get them out of the way, and then set that.
I would just left that to the end, because you can see that in the long questions there's easier marks to be got.
I mean, that's, oh, you mean the A of question 9? Or B?
A of question 9, I probably would have left the whole question because I would have just gone.
I mean, B's nice marks and like.
B is lovely, but
A is not.
it's not as easy to recognize it as lovely straight away. Yeah.
That's the easy answer, I don't necessarily.
Yeah, it's probably the easiest, maybe the easiest 2 marks, not the easiest 2 marks in the paper, but up there. But it's embedded in something. Yeah, it's embedded in something really difficult. Next door to a very difficult neighbor. Okay, let's get on to the long questions now, which I have somewhere else.
I'm so irritated because I could not make it.
Okay, so in question 10, oh jeez, we have. Was there much problems with question 10? Do I need to do it?
I thought there was question 10.
You can't do it?
Well, no, I thought there was.
There's problems.
After I realized I was an idiot. I tried to do 1 minus cosine squared.
Find the roots. Okay.
What?
Okay, so cos squared x minus 3 sine squared x is equal to 0. It tells us to do this and to solve this, doesn't it?
Yeah, cosine squared x equals 3 sine squared x.
Divide sine cos. Tan. Anytime I see sine and cos, I think tan, yeah. So divide everything by cosine x. Cosine x, divide everything by cosine x squared, do I get?
You get 1.
Not mine.
Yeah, you do get one.
But why
And then
do
you
you
get
do
3
it
times.
and
Why
you-
do you get -3?
Hmm?
But in shop, you can still do it.
It is it's not the only way. You can change 1 to sine, yes, and
You
yeah.
could, but that's annoying.
1 minus 3 tan squared x is equal to 0. And then tan squared x is equal to minus 1.
This is factorization.
No, plus 1 over 3. Square root and tan x is equal to plus minus 1 over root 3.
So that becomes redundant because.
Do I have to solve it?
It's root 3 over 3.
What? Oh, it's just in your table. Okay, so then I need to think about my unit circle. Where is tan equal to plus or minus? Well, in 4 spots, but I think in this question I need to go from here to here. So it's the first and second quadrant is both?
ASTC.
Sorry?
Power 6.
Power 6 and
Yeah, so in the first, so the reference angle is pi over 6, so x is pi over 6. The next one is going to be 5 pi over 6. There would be more, but our domain is restricted to just the first 2 quadrants. All right, so part B. What am I looking at? Derivatives. Find the first derivative. Okay, f dash x of, I'm just going to write this slightly differently. I want to use chain rule, yeah, so I like to use that. So this one is going to be multiplied down by the whole power. Cosine x sits there. We multiply it by the derivative of cosine x, which is negative sine x, very good. And that's minus 6 then, 2 times 3, we get sine x times cosine x as well. So that's the chain rule, if you're not sure of that. Put these together. I think I get minus 2 of them here and minus 8 of them, or 6 of them there, so I have minus 8 sine x, whichever way you want to write it, sine x, cosine x.
Oh, right, you can do that.
Okay.
And then you can turn it into 2 sine x cosine x equals sine 2x.
Oh, well, hold on. I haven't got there yet. Is that it? Is that part 1 done? Yeah, find the points in the graph where the first derivative equals 0. So you want to solve this equal to 0. So minus 8 sine x cosine x equals 0. Right, I can't solve it as is. I want just one angle, not a bunch of them shoved together. So minus 4, 2 sine x cosine x. I notice one of my identities. It is in the middle of all this, isn't it? This one goes to sine 2x, yeah?
It's something 2x.
Is it sine? I'll just make sure I'm right. Yes, thank you. Minus 4 sine 2x from our formula booklet is equal to 0. Okay, divide both sides by minus 4. We get sine 2x is equal to 0. Okay, so where is sine equal to 0? These will give us the answers for 2x.
Sine is equal to pi and
So if I'm doing 2x, I must do a full circle, must I? Because if I have x between 0 and pi, 2x is between 0 and 2 pi.
yeah.
Double, double, double.
0 pi and
Okay.
2 pi are where
Sine is 0 here and here.
there and there,
Yes.
0 pi and 2 pi.
I would say 0, pi, 2 pi, and then divide, yeah.
Yeah, and then it's 0 pi over 2
So
pi.
that's 0, that's at pi, that's at 2 pi, stop. I need to go between these two. Divide everything by 2, I get this. Okay?
Divide everything by 2.
Yes, because I have my answers for 2x, not my answers for x.
Yeah, that one felt good when I finished it.
Okay, continue. I don't know, what's next? Sketch the graph. Oh, God. Huh?
Would you like to draw, sir?
I don't really want to draw, but anyway, we've got loads of information here.
It's the absolute value.
Yeah, so it's got to bounce off the x-axis.
Anywhere if you negative it, just
Where is it from? 0 up to 2 pi, is it?
yeah.
Okay, 0, 2 pi. Let's put in our bits of information.
We start.
Oh, I didn't get the full coordinate here. I only got half the coordinate, didn't I?
Oh, we need the coordinates.
Yeah. Yeah, I got to sub it back into the original, which is somewhere over here.
I don't know.
fx is equal to sine squared x. Oh, well, no. Cosine squared x minus 3 sine. I don't think so.
Is it not just
So if I put in 0 into this, I get
0, 0?
cosine 0 is 1. Isn't it?
Yeah.
So, all right, this one gives 1 minus 0, which is just 1. So that point is 0, 1. This point, when I put it in, pi over 2, when I put that in, that's 0, what? Pi over 2 is, yeah, so that's 1, but it's minus 3 times 1, isn't it? Minus 3? Yeah. Minus 3. I'm doing this because I want to find this, but I think it actually asked for the coordinates, didn't it? Yeah. The coordinates, so yeah, I need both. I forgot. And this one is pi, so that's back to this one, that's 1 again. Squared, yeah, okay. All right, so I have these 3 points. I'm going to put them in here. Okay, I'll draw one way and then I'll draw with the absolute value. I'm just going to draw the normal function and then bounce it off the x-axis for the absolute value. So 0, 1 is here. Pi over 2 and negative 3. So that's pi over 2. That's 3 pi over 2. That's negative 3 here. Oh no, I need to go up to pi. Yeah, thanks. Pi over 2 is here. Okay, negative 3, way down here. Okay. Pi over 2, negative 3 is here. Yeah, didn't mean it to be that big anyway. And my last one is here, pi and 1. Okay, very good. Okay, I think that this would then follow that this is kind of... Oh, I have my intercepts as well from earlier, which I have forgotten. Pi over 6 and 5 pi over 6. They might not be perfectly positioned, but they're close enough. Okay, so this in black is y is equal to fx. So now I need to think about what would that look like if it was absolute value and yeah. So in blue is my actual answer and this is at positive 3. It would all reflect up, okay? The point any points we were recording this. Okay, we have done that. Hence or otherwise solve the equality where the absolute value function is greater than 1. So we need to find here and here. Yep. So we need to solve the original function. And this is where the little trick is. The original function's in black. So I need to solve the original function not equal to 1, where it's minus 1.
Because that's the absolute function.
Because we're going to find the reflections. So we're not going to work with the absolute, we're going to look with the original equals minus 1. It's going to be the same answers. So that brings me to bringing everything to one side. And then I go, all right, how am I going to solve this with these sine squares, cosine squares here? Well, I think about Pythagoras' identity. Sine squared, maybe I could use the other one. Isn't 1 minus cos squared x plus 1? Okay, so I get cos squared x minus 3 plus 3 cos squared x plus 1 is equal to 0. So I get 4 cos squared x's minus 2 is equal to 0. So cos squared x is equal to 1 over 2, I think, with the 2 and the 4 cancelling. So cos x is equal to plus or minus 1 over root 2, which is, of course, pi over 4, isn't it? So pi over 4 here in the first and second quadrant, because plus minus. So that's pi over 4, and this one is 3 pi over 4. And that's these two values. So that's pi over 4 here, and that's 3 pi over 4. How do we want it written? Can't remember. Didn't write it down. Hence, or if I solve the inequality.
Just let it go. A little greater than.
So between, yeah. Is it greater than 1? So,
It should be greater than 1.
yeah, so it's going to be, is it pi over 4 up to 3 pi over 4? It's going to be greater than, it's going to be above that. Okay. Was that where the problems lie in this one? That was the problem, okay. Okay, we'll move on. We'll get as much done as we can. Oh, we're nearly done anyway. Time flies. Maybe I just won't. I'll just do the other two questions another day.